Hello, and welcome to today's algebra lesson. We're going to talk about how to multiply polynomials. We're going to start with two binomials and multiply. These are binomials because if you look, they each have two terms. That's where the bi comes from. So they're binomials, going to multiply them. Now, the process of multiplying polynomials together is really just a process of distributing each term of the first through each term of the second. And there are multiple ways this is shown. Some texts show that you do 2x times x, and then 2x times a negative 3, and then you do 5 times x and 5 times a negative 3. And if we do it that way, the 2x times x gives us 2x squared. The 2x times negative 3 gives us a negative 6x. I don't need that plus, but just to show you where that came from the negative 6x. And then in the green, I'd get a 5x, and then a minus 15. You can write it as plus a negative 15 or just minus 15. And then I would combine like terms, and I would see here that I have a negative 6x, a 5x. Those are like terms. They both have a variable of x, and it's to the first power for both of them. So a negative 6 plus a 5 will give me a negative 1x, and we don't usually write the 1. And then we still have our negative 15, and we still have our 2x squared. And what you see there is that the 2x squared comes from multiplying the firsts of each binomial together. The negative 15 comes from multiplying the lasts. We call it lasts. Firsts, lasts. 5 times negative 3, that's where the negative 15 comes from. This term in the middle comes from, first of all, this negative 6x came from the first of this one times the last of this one, and those are the outer terms. And then the 5x comes from the product of the inner terms. And you probably learned somewhere in your education how to FOIL. First, outers, inners, last, and often the outers and inners can be added together. This only works when you're multiplying two binomials. I would rather show you a more universal way to do this that would work for any number of terms times any other number of terms. Now, with two binomials, you want to continue to FOIL because you've learned it, that's fine. But let's take a look at a more robust way that will work all the time. And let's see if I can. No, I don't want to clear that. Okay, let me see. I'm going to have to do some erasing here. Oh, that's a big eraser. It's 2x plus 5 times x minus 3. So I'm going to use the same problem. Times x minus 3. And instead of doing this horizontally double distributing, I'm going to put this in what some people would call a grid or an array. I tend to call it boxes. I have my first polynomial across the top, my second one down the side, and it doesn't matter. I could have put the x minus 3 in the top. It really doesn't matter. But then I'm going to make boxes. So there are 2 on the top, so I get 2 columns. There are 2 terms on the side, so I get 2 rows. And inside each of these boxes, I'm going to put the product, those 2 things multiplied together, of the column above times the row beside. So this one here will be 2x times x, which is 2x squared. And then this one here will be 5x. And then when I move down here, I'm going to start to run out of colors after a little bit here. I'm going to get a negative 3 times 2x, so that's a negative 6x. This negative 3 times this 2x is a negative 6x. And then when I move over to this last one, I look up above, I have a 5. To the side, I have a negative 3. A 5 times a negative 3 is a negative 15. And then I can look to group like terms and I see I only have one x squared term, so I get 2x squared. I have a minus 6x plus a 5x. So I have x and x are the same type of thing, that we call them like terms. So negative 6 plus 5 will give me a negative 1x. We don't usually write the 1, we just write negative x. And then the only constant term, or the only plain number I have, is negative 15. That is the way I do this with boxes. You know, if you wanted to do this with FOIL, that would be fine. But let me show you the nice part about doing this with boxes with another problem. All right, so take a look at that, see if you understand where I got those numbers from. All right, I'm going to erase this, and I'm going to write a new problem. I'm going to change my problem a little bit. I'm going to keep my 2x plus 5. But I'm going to change this to x squared plus 4x minus 7. Now, if I'm asked to multiply this, I can do this process where I take the 2x times the x squared plus the 2x times the 4x plus the 2x times the negative 7. Then I can do the 5 times the x squared, the 5 times the 4x, the 5 times the negative 7. But that gets really, for me, really confusing. When I write all that out, I start to lose track. You can see my handwriting's not that great. What I prefer to do is to make boxes. Now, I guess I can put the 2x plus 5 on top. It doesn't matter. I could put it down the side. I guess if I were doing this, I probably would put it down the side. It doesn't really matter, though. And I have to make the box big enough so each term on the top gets its own column. But then I have x squared plus 4x, and keep the sign with the term it goes with, and then minus 7 on the side here. Now, for the first box here, I get 2x times x squared. Now, x times x squared, you add the exponents, is an understood 1 there. So I get x, 1 plus 2 is 3, so I get 2x cubed from this box. For this box, the top, what's above the box times what's beside the box. When I move over here, I have 5. And to the left, I still have x squared, so this is 5x squared. And then when I move down to this box here, I have 4x times, that's an x, 2x. So I multiply the numbers together. 4 times 2 is 8, so I get 8x squared. X times x is x squared. Then when I move over here, I'm looking, the 5 is above. 5 times 4 is 20, so I get 20x. 5 times 4x will be 20x. 2x times negative 7. When I move back down here, negative 7 times 2 is negative 14. A positive times a negative is a negative. Negative 14x. And then over here on the right column, I get 5 times negative 7, I get negative 35. Now, I need to group like terms. And when I go looking for like terms, I see there's only one x cubed term. So 2x cubed will be part of my answer. That's this one here is the only one with x cubed. But then when I look, I have an 8x squared and I have a 5x squared. I can add those together because an x squared, the variables and their exponents are the same. So I do the 8 plus the 5 is 13x squared. Sorry, I'm experimenting with some different pens here. And then I see the same thing, 14x, 20x. Both of those terms have a type x. It's x to the first power. Negative 14 plus 20. I'm going to add them. The signs are different, so I subtract 20 minus 14. The 20 was positive. It was bigger, so 20 minus 14 is 6, so my answer is going to be positive 6x. And then the minus 35 is the only term in these boxes that is a number by itself, so that is the only thing I can write. That's how I get my answer. Now you can see that this is an organized way of doing this longer problem. I can't FOIL this, so I can't organize it that way. And the reason I can't FOIL is there are 3 terms here. FOILing only works when you have 2 terms times 2 terms. I like this method of boxes for all kinds of multiplying out of polynomials, even when you might normally FOIL. I just thought I'd show that to you as an easier way to organize your work. I hope this helped. Email me your questions.